thing in introducing limits is to show you don't know what a limit is. And I'm not trying to be high and mighty or anything, but it just bugs me like crazy. If I said the limit as x approaches 2 of x plus 7, what is it? 9, right? If I asked you to take the limit as x approaches 3 of x squared minus 9 over x minus 3, what is that? I heard it. Emma? Did you say 3? Who said 6? 6, yeah. How'd you get 6, Max? Ooh, now you're getting way ahead of us, but you could do it that way. I'm going to do it an easier way for right now. Split this into what? X minus 3, x plus 3. And what happens to the x minus 3s? Cancel. What did you do with this first one? You stuck a 2 in, right? And then when you stuck the 2 in, 2 plus 9 is that. So what happens when I stick a 3 in here? I get 0 over 0. 0 over 0 is a, wait a minute, there might be more here. 0 over 0 is, look what happens when I cancel these out. There's where my 0 over 0 is. What's left? 6. 3 plus 3 is 6. Now here's my big question. What is a limit? What did you do? You know how to do these. What is a limit?
I guess it would be based where the point would be based on like the tangents of all the points closest to it or whatever. Like
You're visualizing it well. Keep going. Yeah. Where the graph approaches. That is very important, and I'm going to hit that right now. The limit as x approaches 2 of f of x has to be true if the limit as x approaches 2 from the left equals the limit as x approaches 2 on the right. So what we're talking about there, very good. Here's your graph. Here's my function. This is what we call a point discontinuity. Let's say this is at 2. What is the limit as x approaches 2 from the left? What is it? What is it? 4. What is it when it approaches from the right? 4. So are those the same? Then it's equal to 4. But they have to be the same. They don't. Sometimes you might have something like this. And then that's not going to have a limit. So going back, my question, what's a limit? A limit is a what? Let's go back. What's a derivative? Derivative is a what? Slope. What's an integral? That's the area under the curve. So what's a limit? You've been taught all last year what limits are, right? You did limits. You used them to find derivatives. If I go to a college right now and ask about 5 professors who teach calculus, I would guess maybe 1 or 2 of them would be able to tell me what a limit is. Yeah, you can take a limit, but what is it? No, it's not a point on the curve, but you're close. If I take the limit as x approaches 2 and I get 4, what's 4? Thank you. That's what a limit is. A limit is a y value, and I want you to remember that. All last year, you were asked to take limits, and you didn't know what you were doing because nobody told you what a limit was. It's a y value. It's approaching, yes, it's a special way of looking at y values, but they're still y values. So anytime someone comes up to you and asks you what a limit is, you're going to say what? Thank you, y value. And you are ready for, you can read on this a little bit, talks a little bit more about limits being y values, approaching left and right like we just said, and skip the formal definition. We're not going to do that yet, but go down to the homework. Yeah, here it is here. And just do the ones that are circled here, find those limits for Wednesday. Test tomorrow.